Hello again, everyone. Welcome to the next installment in our Building Your First Custom Mobiflight Device series. In the last episode, we got our toolchain installed, which involved downloading VS Code, GitHub, Python, Platform IO, and the Mobiflight custom firmware template. So today we can start coding, right? Well, not so fast. Those steps got us moving forward, but today we're going to take one step back and think a little bit harder about what we're going to build. So I hope these design tips will help your project avoid some of the pitfalls that only appear late in development if you don't do them. So as briefly mentioned, I'm starting to work on a Garmin 275 EIS, Engine Information System, I think. This could be a really fun project, and as tempting as it is just to jump into the code and get something up on a display, I'm going to take a few steps first that will save me some pain later. So let's go through those today. We'll go through about 4 things here. I'll try to break it up. So first of all, we're going to gather some reference data for our device. This will involve a lot of web searches and maybe watching some videos. We will identify some data sources to populate your device. It'll be really sad if we have a great idea and some great reference, but then for some reason or another, that data is not available in the sim. We'll choose our hardware targets, the display and the microprocessor. That's pretty important before we start coding. We got to know what we're coding for. And then we'll noodle on the plan of attack that we're going to have for actually building this thing out. I like to build incrementally so that I can kind of see progress along the way, and also helps me kind of decide when I'm done. But at the same time, we've got to kind of think ahead so that we're not coding ourselves into a dead end. So let's get started with this. So usually let's get started with gathering the reference data for our device. So usually we want to keep things realistic within our sim. That's a big reason why we build these displays and physical controls, is to up the realism. It's so much more satisfying to twist a knob rather than click a mouse. And I really like having these displays physically on top of my, or at the same place. So if I'm looking around in the sim, I can quickly reference some of these gauges. I'm kind of interested in doing this EIS because I find myself, with the sim being so reliable and there not being a whole lot of riding on it if I do have an engine failure, I find that I don't check my gauges as often as I should in my pre-takeoff, pre-roll, cruise checklists. So I think that having this gauge always up and in my line of sight will help me increase my consistency in checking that and up the realism. So in order to do this, where are we going to figure out exactly what's on this? We could just take a look at this and say, oh, okay, we got a manifold pressure, we've got some engine RPMs, we've got some cylinder head temperatures and some engine gas temperatures, but what the heck is this W on here? Are we going to do that? Anyway, I find a great place to start, if it's available, is by looking up the pilot's guide, the manuals for this. And in that we see that there is an EIS section in this GI 275. And in this, we might find some information that it wasn't available just from that picture. It's like, oh, look at this. There is a fuel planning screen. And it's a touch screen too. Maybe are we going to do the touch screen? I haven't done that before, but it might be fun to try to do a touch control on this. Maybe not for the minimum viable product. This screen might be more of our minimum viable product. So anyway, we're starting to assemble some of this, and this is the kind of bedtime reading that I might actually go through and read more about what are the capabilities of this engine monitor, and start to mentally decide which ones I want to do first, which ones I'm never going to do, and which ones might be good second things. If that information wasn't available, and to supplement it, honestly, I'm going to go over to YouTube and I'm going to start searching for that particular device, that particular display. And we won't get a copyright strike, but what we will do is we'll take a look and we'll see maybe how some of this stuff works. What does it look like when it's up and running in different planes? These things may be configured for different planes, and we'll have to decide, do we want to support a single plane configuration, or are we going to try to go more universal and let the user specify that in some parameters? Again, we're just trying to get an overall sense of how the thing works when we're flying and what it looks like. If for some reason neither one of these are there, or I guess even if they were, the third thing that I might look at is the actual sim and start seeing, okay, how do these things behave in real life or within the sim? That can help me understand whether those, whether all the information I'm going to need to populate it is there. But you've got to be a little bit careful because the in simulation instruments aren't always implemented with the greatest fidelity. So the CAP 140 autopilot's a great example. Different planes will implement that with different levels of fidelity and completeness. So so beware of doing that. So I think that's pretty good. So we've gathered this reference data. What I'll do is I'll start clipping links and maybe relevant sections out of this. I'll grab this reference diagram and I'll start storing that. I prefer to use OneNote. You may have your own note-taking application, but once you find some of these definitive references, it's great to hold on to them. All right, step 2, we're going to start identifying some of the data sources that we're going to need to populate your device. Why are we doing this? Well, if that data is not available in the simulation, it's kind of pointless to make a display for it. Understanding some things are there, some things are not there, and some things are there, but just not in the way you expect them. By understanding what is available there, it's also going to help you with the data types and the overall design. Are these things included as like I said before, are they? What are the units for the manifold pressure? Is this percentage power available within the simulation? What units are you going to use? And are you going to do them as integers or floating points? Just thinking through some of that data can help you with your design. You're going to need all of this as part of your project. So starting to look at what's available isn't going to hurt. And you may identify some variables that you want, but they're just not either there or they're inconsistent. And sometimes you may be able, especially like with autopilots, you may be able to figure out that information by doing a little more complex RPN. I'm sorry, I'll explain that as we go forward. But so how do we get that information? You can use Mobiflight, and Mobiflight has a site called HubHop, which makes it maybe a little bit easier and faster to search for some of the variables that are there. So if we're going to do an engine, we can just come up here and let's take a look for engine. And you want to kind of filter out. You want to really just look at the generic, to be honest. Avoid the payware ones unless you know that you are building your device for a specific payware aircraft or one specific plane. You can do that, but I prefer to build things for generic and then handle the specific planes within Mobiflight itself if that information needs to come from someplace else. So what we'll want to do here is we're just looking at the output. And so we can get things like, okay, engine oil pressure. That was one of the ones we needed to grab, so we can see that that's available. But what we might want to do is jump back and forth between these different devices or these different indicators on our screen and understand which ones are there. Now realize that HubHop is populated by the community. The real definitive list of things that are generally available is in this Microsoft SDK documents. I'll put all the links in the comments or in the description here. And so what we will come here is we'll go to the Flight Simulator SDK documentation and we'll go to the aircraft engine variables, and we might want to read through some of these as well. This is helpful because you do get the definitive answer on these things of how these work and whether you need an index for them or not. For example, if you want to get the temperature of each cylinder head, the index would be that cylinder head number. Or if there's multiple engines, that will be the index of the engine that you're doing. It will also tell you if something exists, but you're really not supposed to use it anymore. So that's another source. If you are building it for payware, often they will have a payware airplane often those will be available too. This, for example, I love to fly the 808 Comanche, and they've helpfully provided a PDF with all of their local SIMVARs. I'm not going to go too deep into the local versus the A versus the K types of SIMVARs, but I'll just say that you're going to want to understand on all of these which variables are available to fulfill everything that you need here. The other thing, once I've identified those, I will use Mobiflight, so you can pop them up here, and you can add a new one, and you can start looking through all the presets that are available. You can also get the list from the sim. That'll get you to the local variables. That's really helpful. But sometimes popping through all those dialog boxes can take a while. So the other thing I like is this SimVar Watcher. This is available in the Microsoft Flight Sim SDK. It might also be available for download online. But this is pretty much the same thing, but it has everything right here. It's a little bit faster and more responsive than Mobiflight. And if I don't have the sim running right now, but if I connect, it will populate these things as I go forward. I tend to use this quite a bit, and then I will go over to Mobiflight and bring those things in. So that's our plan of attack for data. I guess the last thing you can do if it's really hard is I have successfully used ChatGPT and Claude to help me find those SIMVARs. If it's not obvious, but beware, the generative AI can make up SIMVARs that you would hope would exist, and they don't really. The final thing that I have done in pinches is open up the SDK, the development SDK. Again, I don't have the sim running, so I can't show it to you. There are videos on YouTube about that, about how to find the controls that are done with the SDK. And the final last resort I have done too is I've read the source code for some of the instruments. For example, on the G1000, that is open source, and you can go in and you can figure out how did they get this variable, and do they make it available as a SIMVAR to me, or what are the calculations they're doing with the core SIMVARs to figure that out. That is maybe a 302 level course that we can do someday, but for now, that's what I'm doing. The most important thing to consider here is finding all of those, or at least the critical ones, the make or break SIMVARs that you're going to need to create this device. And after looking through this, I'm fairly convinced that I can get everything on this page. So let's go on to our next thing. All right, next up, let's talk about choosing the hardware, the display, and the microprocessor you're going to use. You only have a few choices. Well, you only have a few choices for your microprocessor. You have tons of choices for your display. And again, we could go on this particular topic for an hour, but let's try to keep it tight. Usually, I am using one of my favorites is this Raspberry Pi Pico. I'm using everybody's favorite cheap Chinese website here. These things are super cheap, $1, $2 a piece. These don't have any Wi-Fi or network connectivity, but that's okay. We don't really need them for our stuff. They have a lot of I/O pins, and it's pretty easily programmable. They're pretty fast, and they're very capable. You can certainly drive a lot of different displays with that. My other choice, and it is supported out of the box with the custom firmware. The other one I really like to use are ESP32, or more accurately, the ESP32S3s are a little more capable. These tend to be a little more expensive, usually around $3 to $6 a piece. And they do have Wi-Fi that we don't really need. They have Bluetooth that we don't really need. I guess we could start experimenting with that. But these are nice, high power, and you can drive. They have more memory, and they have a little bit better speed. And so I will use these, but really the way I really like to use them is in the integrated modules. So I don't know, let's try, is there... the ESP32 display. Here's one of my favorites. This display, this 4-inch display, and this is what I'm likely going to use. I've seen these at prices ranging from $18 to $30. But this is a nice integrated module. You can see that it's got an ESP32 and the display right there. It saves you a lot of headaches with wiring, and it's very durable, which I can't always say about some of my hand-wired stuff. It's also a pretty fast display. So I tend to lean towards RP2040, the Raspberry Pi Pico, when we're talking about processor, or the ESP32 S3. If we're looking for displays, you've got a lot of display possibilities, and this is often where I'll start. Is okay, what does the display of the device I'm building look like? How big is it? Is it color or not? Does it need a touch screen or not? And how am I going to do it? So something with more of a rectangular, maybe if I was going to build the engine monitor in the Comanche, is more of a large rectangular shape. Or do I need a square? The thing that you've got to watch for a lot of cases is the size of this. 1.54 inches is very small. And there's sometimes, that one was actually realistic compared to the hand size. I've seen ones where it's a 1-inch display, but it'll look like it's like 5 or 6 inches because of the size of the hand that they've overlaid on it. That happens with a lot of these circular displays. You'll see that this is really only 1.28 inches, but sometimes they'll have somebody, it's the size of a watch face, but they'll show somebody with it and it'll look like it's a lot larger. Anyway, be careful of that when you're shopping. Searching for Arduino display will usually get you a lot of candidates. You can go to some of the specialty shops like Waveshare. I think Waveshare has a ton of different displays that will work with different things. The displays will have different, here's like a nice 4-inch round. This would be a great candidate for what we're doing. I'm not a fan of that price though. And so I think that for half the price, I think I can get away with the square features. That's really tempting though, isn't it? It has touch, 720 by 720. That's actually too high a resolution. I actually want it lower resolution. You'll be hard pressed at that resolution to get the speed. You'll run out of memory, basically trying to write a 720 by 720 quickly. The thing though is what you want to watch for here is the type of display it is, what kind of interface it has, whether it has an SPI, an I2C, or a parallel display. And you definitely don't want an HDMI display. So a lot of these are HDMI. You don't want that unless you're doing a pop-out. So maybe if you want to do a pop-out window like a G1000, but you don't really need to be doing a custom device for that. So anyway, you've got a lot of displays. You can always go to Amazon as well. Search for Arduino display, see what comes up there. You'll find a lot of options that might be what you want to look at here. This one's a little bit easier to code to. Then you'll be choosing some libraries to drive that. We'll talk about that later though. Okay, so we've chosen our hardware. I'm going to use that all-in-one module, that 4-inch 480 by 480, because it makes my life a lot easier. So I've got the display. I know I've got a working driver for that, and that's going to use an ESP32 S3 microprocessor, which isn't in the core, but Ralph has kindly figured out how to make the ESP32 work. And so we'll get to that when we're actually cloning the framework repo. We'll use a different one than I used in that very first lesson. All right. We've gathered some reference data for our device to see what we're going to have to draw on the screen. We've identified the data sources that we're going to use to populate our device. We've chosen our hardware, our display, and our microprocessor. So let's get our plan of attack going forward here. So the next thing I'm going to do is get my screen working in a base configuration. I generally, if I'm using a new screen, one that I don't have previous experience with, I will do that outside of the Mobiflight framework. I want to just see some hello world on that screen and get that going. So our first step is get screen working. That'll test our tool chain. We'll have to go in and we'll pick some drivers and we will get it configured. I'll tell you, once you can get that going, you are almost there. A lot of that can be hard, frustrating work, and we'll start working on that in our next video. The thing that we're gonna, so we'll get our screen, well, I guess we'll get our screen wired up first. In our case, that's going to be easy because it's a integrated module. It's already wired. But then we'll get screen hello world working. That involves configuring everything and getting the tool chain nice and working. And then we're going to get screen to display anything from Mobiflight. So this will be, we'll start rebuilding this with our Mobiflight firmware, and we'll just try to get something to appear on the screen. We're not going to worry about making the screen pretty yet. We're just going to start like displaying, I'll probably just display the manifold pressure and the RPM. That'll get our fonts going, our fonts in the right size. We'll be able to choose that. We'll be able to get some of the sizing working. We'll start to work on the pixel layout, and we'll make sure that everything's working end to end with Mobiflight. And then we get to the fun part, which is start adding features. I think that's enough for today. So I guess if you've got an assignment right now, it is to go figure out, go gather that reference data, watch a few YouTube videos and read some manuals so that you really understand how the device that you're trying to design is going to work once you get your code working.